Radius of Earth according to this question is capital R, whereas a point mass which is placed in an orbit whose orbital radius is 2r and the height is r, that is equals to the radius of the Earth, which means that if this is a point mass at this point which has a mass m, so you can say that its orbital radius is 2r right now. So actually this point mass was initially present on the surface, so it means that this is an initial position and this is a final position. So when we have raised this mass from initial position to the final position, how much work was done according to the question? This is asked. So the first formula that will come to your mind is this formula, F as cos theta. But you cannot apply this formula in this scenario because the gravitational force is proportional to r square, inversely proportional to r square. So it means that this gravitational force is a variable force because you are moving a mass to a larger distance, to the distance r above the surface. So you cannot apply this formula to calculate the work done. Okay, so then we have a next option that is obviously law of conservation of energy. So this is a surface and this was a mass, point mass initially at this point. So when it was at this point, what was the total energy that it possessed initially? That is, of course, there's a no initial kinetic energy, but there is a potential energy due to attraction of the Earth, and that is obviously negative g mm over capital R. This is an energy possessed by this object initially, and where you are taking this object, you are taking finally this object to the point where its distance above the surface is capital R. And at this point, what is the energy, total energy? So once again, if we will assume there's a no kinetic energy because we have raised this mass, so it means it is at rest. But due to gravity, it has still, we can say, potential energy. That is the final potential energy. And what is that? That is negative g, capital M is a mass of Earth, small m divided by r is a height, plus r is the distance from the center to the surface. So 2r is an orbital radius, so that is negative g mm over 2r. So if you take a difference of these two energies, that will be equals to the work done, because we know that the work done is equals to the change of energy, and specifically change of potential energy for this question. So that should be, it's a final energy minus this is the initial energy. Okay, so then work done is equals to negative g mm over 2r. So that is g mm over r. For more simplicity, you can take capital G m small m over r, common factor out. So what will be remaining behind that will be 1 over 2, negative 1 over 2 plus 1, which is equals to 1 over 2. So that is gmm over 2r. But what we see here in options, that small g is written, and you know also that the small g is a field strength which is equal to gm over r square from the surface, because they say on the surface is g. So you can replace here, because for example, if I multiply r and divide by r as well, so then it may be written as 1 over 2 small m outside, inside you can say gm over r square, whereas there's another r in numerator, so which I should write here. So what is this? This is gm over r square, is obviously, you know that it is small g, so it is mgr over 2 is the final answer. This is a total work done to raise the object from a surface to the point where the distance is r from the center. So it should be C then.